Today, we're talking about graphing the graphs of quadratic functions. Okay, a quadratic function is a function with an x squared in it. Have we looked at this notation before? I can't remember. F of x?
Yeah.
We've seen that before. It's the same thing as y equals x squared. So you know, normally this is the x-axis and the y-axis. Well, this could also be like the f of x axis. Okay, the f value, it just means the f value depends on what you put in for x when x is squared. Okay, so if I wasn't sure, have we seen a graph like this before? If I wasn't sure what this graph would look like, how would I figure it out?
That's a good question.
We've done this trick a lot before. You would make a table and plug stuff in. So let's plug in these kind of standard 5. If I plugged in -2 for x, what would that equal? -2 squared is +4. -1 squared, 1, 0 squared, 1 squared, 2 squared, 4. Okay, so there's some symmetry here. It goes 4, 1, 0, 1, 4. Kind of goes down, hits the bottom, goes back up again. So what does it look like? 0, 0, 1, 1, -1, 1, -2, 4, right there, 2, 4, right there. Have we seen this before? I can't remember. I think we kind of did a little bit on a couple of the homework problems a few chapters ago. This shape is called a parabola. And anytime you're graphing a quadratic, an x squared, that's basically what it looks like. Okay, the bottom of the parabola, right there, is called the vertex. That word gets a lot of usage. It's the corner of an angle, the corner of a polygon, the bottom of the bottom of a parabola, it gets used a lot. Vertex. So right now the vertex is at 0, 0. This is like the standard, the simplest you can get. Just y equals x squared. Okay, what do you guys think would happen to the graph? See that color? I like that shade. Okay, what do you think would happen to the graph if I put a 2 right there? If I can, 2x squared.
Just like, go like right, 2,
All right, let's see what happens. If I plug in 0, 0 squared times 2 is 0. If I plug in -2 squared is 4 times 2 is 8. If I plug in -1, 1 times 2 is 2. Plug in 1, 1 times 2 is 2. If I plug in 2, 2 squared is 4 times 2 is 8. Okay, what's happening? So we got 0, 0 still. We still have -1, 1, and -1, 2, and 1, 2. And instead of 2, 4, it's 2, 8. All right. So yeah, it's steeper. It's actually going up, I don't know if you can tell, but it's going up twice as fast as the other one. So this one's only 1 high right here. This is 2 high. This is 4 high. This is 8 high. So it just doubled. I mean, kind of makes sense. It just doubled the height. So guess what would happen if I did like a 1/2 right there? It would only be it'd go up half as fast. It would actually look kind of, it would look like this. It would look broader. Or I think the word the book uses is flatter. That one got off somehow. So when you multiply by a number less than 1, it goes up slower and it gets flatter. If you multiply by a number bigger than 1, it goes up faster and it gets steeper. So the book the words the book uses are steeper and flatter. It's not very technical, but that makes sense. Okay, let's throw one more in here before I move on. What do you think would happen if I put a negative right there in front?
Would it start
Upside down.
like that?
Yeah, basically you'd still get all these same numbers, but they would become negative. Well, is there a negative 0? It's, well, kind of, still 0. So yeah, it does go upside down. So it would just be down here like this. Okay. Couple things to notice. So that's what a negative in front does. So parabolas, they get steeper and steeper forever without ever going straight up. Okay, the domain is all real numbers. It goes forever right and forever left. And parabolas, they're always symmetrical. Do you guys know what the word symmetrical means?
Same on both sides.
Right. Like people are kind of symmetrical, at least on the outside. We look the same on the two sides of our body. On the insides, it's kind of all mixed around, but you know. Like the stomach's on one, a little on one side, the heart's a little bit on the other side. Anyway, yeah, this line right down the middle here, they call it the axis of symmetry because both sides of the parabola are the same around that line. Hold on. All right, so notice when the graph had a negative, it went down, and that makes the vertex at the top of the graph also. Okay, what a big mess. Let's jump in.
Yeah.
See what we got here. 1 through 8 says find f of 0, f of 2, f of negative 1. And f of 4. What do you think they mean by that? Find f. What do you think this means, f of 0?
0.
It means find the value of the function when you're replacing the x with a 0. So in other words, you just do 0 squared. Okay, so f of 2, what's the value of the function? It's kind of like the y value, when you put 2 in for x. 4. Okay, so it's not trick, we're just plugging stuff in basically. So f of negative 1, what's the value for the function when we replace the x with negative 1? So if you put this in your calculator, you would get it wrong. Why would this be wrong? Okay, because you want to square all of x, you want to square all of negative 1, and if you don't have parentheses, order of operations makes it square the 1 and not the negative. So this should come out as positive 1. If you don't put the negative in parentheses, it would come out as negative 1. Negative 1 times negative 1 equals positive 1. Okay, and then the last one was f of 4. So that would be 4 squared. 16. All right. I'll make you guys do it.
Yeah.
So number 3 is x squared minus 4. Where did we leave
I
off?
feel like we left off at Brianna. Like we finished with Brianna. We did this row, and then it moved back there.
I think you're.
No,
No, I swear.
I think Brianna was up to bat actually.
Yeah,
I got you, Brianna.
I agree with Gavin. Whatever Gavin says is true.
That's
I'm trying to remember. I don't really. I feel like we did finish a row or something.
We
was
finished
this
this
row.
row, I
Yeah.
remember.
So now we're at this row.
Yeah,
I
so
did
we're
number.
Miranda.
We're at
I
Miranda.
think you're correct. Hold on.
No, I promise I remember.
We finished this
No,
row.
I think
We
we're
finished.
AJ.
But
I think I did number.
I remember.
Okay.
Let's start the back rows.
I don't care that much.
Yeah, the back row hasn't had to do anything forever.
The background,
He asked another
the
question.
background never.
Okay, all right, hush. So on number 3, the numbers we're plugging in every time are in the directions. It's 0, 2, -1, 4. So this time it's x squared minus 4. So Mallory, if I plugged in 0, what would I get here? Shh. Huh? -4? Yeah, 0 squared minus 4 is just minus 4. Okay, if I plugged in 2, 2 squared minus 4. I plugged in -1, -1 squared.
Negative 3.
Yeah. And if I plugged in 4, 4 squared minus 4.
12.
Yeah. Okay, number 5, -2x squared. Alright, how am I gonna do this? Alright. Josiah, awake. If I plug in 0 here, Josiah, what will I get? Did you say it? I think you did, but I'm deaf.
So we just, I gotta find, it says find F2. We haven't done that at all.
Right. That's what we've been doing. Yes, we have been finding f of 2.
We have.
Yes, among other things. Okay, if I plug in 0 right here, Josiah, what do I get? What is 0 squared? Times what's 0 times -2? 0. That would be the first one. So, Ryan, when it says find f of 2, that means what you get when you plug in 2. That's what we've been doing. So we just plugged in 0. Now we're plugging in 2. So, Josiah, 2 squared times -2. No, it'll be negative, but 4 times 2 is 8. So it'll be -8. All right, and if I plug in -1 squared, that's -1 times -1 times -2. Yeah, notice I am using order of operations because I'm doing the exponent first, multiplying second, right? Doing x squared first times -2. All right, and then if I plug in 4, Josiah, 4 squared. Forgot that one. It's just 4 times 4, so that'd be 16. 16 times -2, you guys know that one? -32. All right. Number 7. 3x squared minus 7. Oh shoot, I just remembered I forgot an example. So, if I was graphing this, what do you think the -2 would do to this graph?
Bring it down.
It would bring it down to. Yeah. That's right. So the vertex would be like at 0, -2, and it would just be like normal. Anyway. Okay. So what were we plugging in? 0, 2, -1, 4, I think. Let's see. Alright, this one's kind of a mess. Leah, if I plug in 0 right here, what's 0 squared?
0.
What's 0 times 3? What's 0 minus 7? No. 0 minus 7. It's kind of like if you have $0 and you lose 7, and you're 7 in the hole. So it's just -7. Okay. And then if I plug in 2, what's 2 squared? What's 4 times 3? 12, and then 12 minus 7. 12 minus 7 is 5. Okay, and then if I plug in -1, what's -1 squared? Yes, it just means -1 times -1 is 1. Times 1 times 3? 3. And 3 minus 7. Okay, 3 minus 7 is going to be like the opposite of 7 minus 3. So 7 minus 3 is 4. It's like $7 take away 3. If you have $3 take away 7, then you're in the hole. So that would be like a -4. Okay, and then 4 squared. Did you hear what that was when I was talking to Josiah? 16. Okay, 16 times 3. You probably need your calculator for that one. It's 48 minus 7. 41. All right. Moving on to the more interesting part.
I know, that was interesting.
You were fascinated by that?
Yeah.
Huh?
Were you up for it?
5?
Like, were you just?
Just ask me at the end, I guess. Okay. Number 9. So listen closely because there's only 2 odd problems. So, okay. Number 9 starts with this. And the first question is, which direction does it open? So a parabola either is going to open up or down. Now, what makes a parabola open down? If there's a negative in front. So on number 9, is this going to open up or down? Up. Because it is positive 4x squared. If there was a negative there, it would flip it upside down. All right. The next section is the vertex section. So when it says at, it means what are the coordinates of the vertex. Now, what is this 4? What's that 4 going to do to the graph?
Multiply by 4,
No.
quadruple it.
Makes it, no. It makes it 4 times steeper.
Yeah.
So, in other words, it would just be like really skinny, go up really fast. So, does the parabola move? Or sorry, does the vertex move? No. The 4 makes it steeper, but what moves the vertex is if you do like a +2 or -3 out here. This would move it up or down, but this just makes it steeper. So, the vertex is still at 0, 0. Okay, the next question is minimum or maximum. So is the vertex the minimum point on the graph or is it the maximum point on the graph? It's minimum because that just means it's at the bottom. It's the lowest it goes. So it will be maximum if it's a negative graph, then the vertex is a maximum. But because this was a positive, the parabola is going up and the vertex is at the bottom, and I'll just put minimum, I guess I'll write it out. Minimum. All right, the last one, compared to the shape of f of x equals x squared. So compared to a normal graph, how's this one going to look? Yeah. The word we're going to use is, I said skinnier, steeper, goes up faster. The word we're going to use is steeper. If the number in front of x squared is bigger than 1, it's going to go up fast and it'll be steep. If the number in front of x squared is less than 1, like a fraction, it'll go up slow and we'll call that flatter. And if the number in front of x squared is just a 1, which means it won't show up, it'll be the same as normal. So those are kind of the 3 options. Steeper, flatter, or same. Those are the 3 options for that one. All right. Number 11, f of x equals negative x squared. Okay, let's start with this. Now, these sketches aren't like have to, but they just make it easier here. What's this +4 going to do to the graph?
Move it
up 4. So that means the vertex is going to start right there. What's the negative going to do to the graph?
Make it wide.
Go down.
No, upside down, my bad.
Okay, so it looks something like that. Now the first question, what was the first question? Is our parabola going to open up or down? Down. Because it's a negative x squared. The second question was, what are the coordinates of the vertex? Right. Because the graph moved up 4, it's no longer at 0, 0. It is up 4, which is at 0, 4. All right. What was the next question? Oh, is this a max? Is the vertex a maximum or minimum point?
Maximum.
Maximum. It's at the top. So basically, if your x squared is negative, the vertex is going to be at the top. It's a maximum. If the x squared is positive, the vertex is going to be at the bottom and a minimum.
How'd you do a fraction? I forgot.
Okay, the next question, is it flatter, steeper, or same as normal? What's the number in front of x squared here?
-1.
-1. Is that steeper or flatter than normal? Neither. So a 1 in front of the x squared just means it's kind of a normal steepness. All right, on 10 and 12, they both have fractions. What does a fraction do? Makes it go up slower, it's flatter. Okay. Number 13, we actually have to graph these. I kind of already graphed 13 because it's the basic. It's the basic x squared graph. Okay. Let's start by identifying where the vertex is. So if it's just y equals x squared, where's the vertex going to be? 0, 0. So I'll start off with the vertex. 0, 0. When you plug in x is 0, you get 0 for y as well. I'm just going to plug in 2 x coordinates that are on one side of the vertex. So 1 and 2. Or I could have used -1 and -2. But if I plug in 1, what do I get here? 1. If I plug in 2, 2 squared is 4. Okay. Now, if I'm starting at 0, 0 and going up, I don't really need a negative y-axis. So you might make your picture look like that. Okay, so 0, 0, right there, the origin, 1, 1, and 2, 4. So I just found one side. Why are we getting more graph paper?
Because I didn't get one.
I thought I gave everybody one. Did everybody get? Did I miss the front row or something? Oh. Whoops. Okay, Jesse, grab some graph paper and here. Just give a stack over to the front row. Right. So I'm gonna, instead of plugging in like -1 and -2, you could do that. I'm just gonna use symmetry here. Just mirror this point over. It's right there. mirror this point over 2 steps away from the y-axis, and it's right there.
Do you need us to show the second part of the, whatever it's called, or can we just, like...
The second part?
Like, do we have to do the second half of plugging in
Pretty sure.
No.
Just answer.
If you get those 3 points, that's fine. But I do expect to see all 5 points on your graph. Not just a graph that's kind of floating in space. I want to see all 5 of these points. So the vertex is one of them. And there's 2 on either side of the vertex. You could keep going, but the numbers get really big. Like if we plugged in 3, it'd be 9. Plugged in 4, it'd be 16. All right, are we good on 13? Okay, so let's do 15 up here. X squared plus 2. All right. Actually, for today, it's kind of, yeah, it's a little bit easy. All of the parabolas are in the middle. So for your coordinates, you could just use 0, 1, and 2. All the parabolas, all the vertices, all the vertexes are going to have an x coordinate of 0 today, not tomorrow. Because the parabolas are just going up and down, but the vertices are still in the middle. So if you just want to plug in 0, 1, and 2, that should work okay. Now if I plug in 0, what do I get? 0 squared plus 2 is 2. If I plug in 1, 1 squared plus 2, and 2 squared plus 2. So let's graph those. So 0, 2 is where we're starting. That is the vertex because the graph is up 2. 1, 3, 2, 6. So that is the right side of the parabola. And the left side just mirrors it. X squared minus 1. Okay. What is the minus 1 going to do to the graph?
Move it on down.
Right, it's going to move down 1. So my vertex, if I plug in 0 for x, I get negative 1. The vertex is down 1. If I plug in 1, 1 squared minus 1 is 0. If I plug in 2, 2 squared is 4 minus 1 is 3. So 0, negative 1 is the vertex. 1, 0, 2, 3.
Indeed.
I don't guess I didn't do this here this morning.
The weather's supposed to be really nice, probably cold in the morning though. Okay, 19. Negative x squared plus 2. All right. What is the plus 2 going to do to the graph? It's going to move it up 2. So when I plug in 0 for x, I get 2. The vertex is at 0, 2. But what's the negative going to do to the graph?
Move it a little right.
No. It's going to flip it upside down. So when x squared is negative and the graph is negative, it just goes upside down. If I plug in 1, in this case, should I square the negative or not? Not. So we're just squaring the x value, not this negative. So when I plug in 1, on the calculator it would look like this. It's 1 squared is 1, and then you add the negative. So that actually is negative 1. 2, oh, I forgot to add 2. Plus 2 is positive 1. 2 squared is 4. Negative 4 plus 2 is negative 2.
Why would you not square the negative?
Because this is just telling us to square the x. If they wanted us to square the negative, well, if they wanted to square the negative, there wouldn't even need to be a negative. They would have to have done that. Okay, we're squaring the x. But if the x was negative, we would have to square that negative. So, like if we were plugging in x is negative 2, we would add it in negative 2 squared. So this negative would have been squared, that one would not have been. Okay. 0, 2, 1, 1, 2, negative 2. So it is going down. Dang it. And close enough. All right, 21. Probably better get another sheet up here. 21 says 2x squared minus 3. Okay, what's the minus 3 going to do to the graph? Moves it down 3. What's the 2 going to do to the graph? Makes it go up twice as fast. So it's going to be start lower and it's going to go up fast. So kind of low and then skinnier. All right. So if I plug in 0, 0 squared times 2 minus 3 is negative 3. If I plug in 1, squared is 1 times 2 is 2. 2 minus 3 is negative 1. If I plug in 2, 2 squared times 2 is 8. Minus 3 is 5. So this one's going to start at 0, negative 3. Right there. One, negative 1. 2, 5. So quite a bit steeper. If we plug in 2 on 22, let's see, that would be 16, 11. Yeah, 22 goes up pretty fast. So it'll need to go down to -5 and have to be able to go up to 11. So it's kind of tall. But the rest of them aren't that tall because they're all just x squareds mostly. 14, I guess, has a 2 on it. So 14 will have to be able to go up to 8. All right, 23. I don't know if I can fit this on a graph. F of x equals -3x squared. Okay, what does the negative do? Makes it upside down. What does the 3 do? Makes it steep. So it's going to go down very quickly. But the vertex has not moved. So it starts at 0, 0. I plug in 1 squared times -3, I get -3. If I plug in 2 squared is 4 times -3, I get -12. So that will need to go down 12. Zero, 0, 1, -3. To -12. Barely made it big enough. On 24, some of your answers should be fractions because you're multiplying by 1/3, unless you use multiples of 3. So if you use well, I don't know if you want to go out to 6, but if you use 0, 3, and 6, those numbers are divisible by 3, so it would work. You might just want to use fractions though. Like the nearest, you could still use 0, 1, and 2 for your x, that'd be fine.